In today's video and class, we are going to look at recrystallization. So we will start by looking at what recrystallization means. So first of all, recrystallization is a purification technique that separates a pure compound from impurities by dissolving it in a solvent and then slowly cooling the solution. So the principle here is that the solubility of most solids increases with increased temperature. And this means that as temperature increases, the amount of solute that can be dissolved in a solvent also increase. And one key thing that we have to notice that the process of recrystallization works best when the compound is very soluble in a hot solvent, but not very soluble in the same solvent when it's cooled. Recrystallization is used to purify solid compounds, which tends to be more soluble in hot liquids than in cold liquids, as said earlier. And what you also have to note is that during recrystallization, an impure compound, and as we can see, this is our impure compound over here, is dissolved in a suitable solvent. So this is our suitable solvent and heated until the solution is saturated. So as you can see over here, and this is indicated by the rise in temperature over here, and then allowed to cool. So after heating it to a higher temperature, we allow it to cool, and this cooling process leads to the formation of relatively pure crystals, and ideally any impurities that are present will remain in the solution and will not be incorporated into the growing crystals. The crystals are then removed from the solution by filtration. So now if you should look at this picture, so we have an impure benzoic acid and a pure benzoic acid. So this is the impure benzoic acid and this is the benzoic acid after recrystallization. And once again, we also have to notice that recrystallization is not generally thought of as a separation technique, but as a purification technique. However, if the solubility properties of two compounds are sufficiently different, recrystallization can be used to separate them, even if they are present in nearly equal amount. So this is the only situation or condition that recrystallization can be used to separate two compounds. And also recrystallization works best when most impurities have already been removed by another method, so such as the extraction or the column chromatography. And also a successful recrystallization depends on the proper choice of solvent, as the compounds must be soluble in the hot solvent and insoluble in the same solvent when it is cooled. And this is one key thing that we have to note in recrystallization, and that happens to be the choice of solvent or the suitable solvent that is needed. And also the rate of cooling determines the size and quality of the crystal. Example, so rapid cooling favors small crystals and slow cooling favors the growth of large and generally purer crystals. Although the terms crystallization and recrystallization are sometimes used interchangeably, technically they refer to different processes. So the main difference is that crystallization is the process of forming solid crystals, whilst recrystallization is a method for purifying solid compounds. And also, the solid crystals formed in crystallization contains trapped impurities. Therefore, recrystallization is used to remove these impurities by dissolving the crystals or solid compounds into solutions and then changing the conditions to allow pure crystals to reform. And one thing that we also have to notice that recrystallization produces a purer final product. And for this reason, experimental procedures that produce a solid product by crystallization normally include a final recrystallization step to give the pure compound. So now let's just look at the 5 main steps involved in the recrystallization processes. So the first step has to do with the determination of the suitable solvent. The second step is to dissolve the impure compound in the suitable solvent. The third step is to cool the solution. The fourth step is to collect the crystals, and the fifth step is to dry the resulting crystals. Now, so if you want to dissolve the impure compound in the suitable solvent, we add a small amount of solvent to a beaker containing the impure compound. So as you can see over here, so this is our impure compound and this is the suitable solvent, so we add it to it. After that, we heat the beaker until the compound is completely dissolved in the solvent. So after adding this, we heat until the compound, so which is our impure compound, is completely dissolved in the solvent as seen over here. So the next is to cool the solution. So we slowly cool the saturated solution to room temperature. So we allow this to cool and we cool further on ice to allow crystals to form. So as you can see, so this is the formation of crystals at the bottom of our beaker over here. So after the crystals have been formed, so we then collect the pure crystals that are formed by filtration, and finally the crystals are dried by leaving them in an aspirator and a glass dish to wait a while longer. So now let's look at the various steps into detail. So you start by looking at the first step or process in the recrystallization process, and that is the suitable solvent detection. So first of all, what you have to notice is that before carrying out the actual steps of the recrystallization process, you must first determine the suitable solvent for the impure compound by doing the solubility test. And any compound for recrystallization usually exhibits one behavior of the general three. One, the compound is either with higher solubility in both cold and hot solvents, or the compound is with low solubility in both cold and hot solvent, or the compound is with low solubility in a cold solvent and high solubility in a hot solvent. So what you have to notice is that solvents that show the first two behaviors, and these are like compound with high solubility in both cold and hot solvent and compound with low solubility in both cold and hot solvents, are not suitable for the recrystallization process. And the suitable and optimal solvent that can be used as a recrystallization solvent is the one that has the compound being insoluble at low temperatures, highly soluble in high temperatures, and sparingly soluble at room temperature. So the next step is dissolving the solute or compound in the suitable solvent. So the next step after determining the suitable solvent is adding the solvent to a beaker containing the compound with the impurities. We then heat the beaker until the solute is dissolved completely. So now let us look at the third step, that is cooling the solution. So first of all, in this step, we allow the solution to cool slowly, first in the open air, and then allow it to continue cooling on ice bath. And the slow cooling here is important to obtain purer crystals that will precipitate at the bottom of the beaker. And once again, what you have to know, so the slower the cooling rate, the larger the formed crystals and the purer they are. So obtaining the crystals by filtration. So the pure crystals that are formed at the bottom of the solution is collected and isolated from the solvent by filtration. And this can be done either by a vacuum filtration or a gravity filtration. So let's look at the vacuum filtration. So the vacuum filtration is the common technique used to isolate the remaining crystals in the beaker. And by using an aspirator or a vacuum pump, the solution is created and the process of filtration is done. And by using a Bachner funnel, anything remaining in the beaker is poured. So this is the part of the vacuum flask or beaker that is connected to our vacuum pump over here, and this is our Bachner funnel. So, and this is our porous plate, like which are plate with holes, and this is our moisture filter paper plate on it, and this is the filtration material as you can see over here. So this is just a setup showing how a vacuum filtration is done. So now let us look at the second type of filtration, and this has to do with the gravity filtration, and this is also a setup for the gravity filtration. So this is our filtered liquid, and this is also our funnel, and this is our filter paper over here, and these are the liquids and the insoluble solids seen over here. Now, so what you have to note is that gravity filtration uses gravity to separate insoluble solids from liquids or solvents containing soluble or dissolved solids through a filter paper. And this method can be used if there are no crystals seen in the beaker. And one important thing we also have to notice that gravity filtration depends on the addition of activated carbon to the solution, then letting the new mixture, so which is the activated carbon and the solution, boil, and by a funnel system, so the new mixture is transferred to a new beaker that contains the boiling solvent. And the excess carbon here is removed by the filter paper in the funnel, and also after slowly cooling, large crystals are formed and present at the bottom of the beaker. So the fifth step is allowing the resulting crystal to dry. So after rinsing the crystals with a small amount of ice cold solvent, we allow the crystals to dry by one, leaving them in an aspirator. Two, by transferring them to a glass dish to air dry. And we also have to note again, so the crystal's purity can be tested by conducting a melting point determination test, and we are not going to look at this into details. So now let's look at the types of impurities that are normally seen in compounds during the recrystallization process. So basically, there are three different types of impurities. So we have the insoluble impurities, we have the colored impurities, and the soluble impurities. So we will pick them and look at them. So for insoluble impurities, so this type can be removed easily by dissolving the compound in a hot solvent, filtering the solution to remove the insoluble impurities, so as they are left behind in the filter paper, then evaporating the solvent to obtain the solid compound. And what you also have to notice, so because they are insoluble, they will not be able to dissolve in the solvent. So by using filter paper or gravity filtration, we can easily separate them. The next is the colored impurities. This type can be removed by the same steps in the case of insoluble impurities, but with an additional step. So over here, the additional step is by adding activated charcoal after the compound is dissolved in the solvent. So the role of the activated charcoal here is to absorb the colored impurities. And when we talk of colored impurities, so like they are normally seen as they are impurities that changes the color of the solution. So the role of activated charcoal here is to absorb the colored impurities, then it is left behind in the filter paper. Now let us look at the soluble impurities. So for the soluble impurities, they are able to dissolve in the solvent with our pure compound. So this type can't be removed by filtration because the impurity solubility is similar to the solubility of the desired compound. So let's see how we can remove these soluble impurities. One, by conducting the solubility test to determine the suitable solvent. That is a solvent at low solubility. So the compound that has a low solubility when the solvent is cold and has a high solubility when the solvent is hot. So after that, we dissolve the desired compound with the soluble impurities in a minimum or near or at the boiling solvent. So after that, so cooling the new solution slowly and without interruption. And as a result of cooling the solution, the solubility of that is the compound and the soluble impurities decreases. So the solution becomes saturated with the desired compound and the process of crystallization begins. And what you also have to note is that only the desired compound crystals formed as crystal formation is a highly selective process. On the other hand, the soluble impurities will remain in the solution even after the solution has cooled because they are found in smaller amount, and so the solution is never saturated with impurities. And also after removing the solvent and the soluble impurities, a final rinse with ice cold solvent is done to clean off any residual soluble impurities. And finally, after evaporating the solvent, the pure crystals of the desired compounds are present. So these are the ways by which we can remove soluble impurities in our compound during recrystallization. So now let's look at the test protocol. So we'll start by looking at the materials needed. So we have our extraction solvent, the filter paper, acetone, ice cold acetone, boiling water, steam bath, stirring rod, and beakers. And one caution that we have to take note is when performing this experiment is that the acetone, the diethyl ether, chloroform, and hexane causes eye and skin irritating, and their vapor is irritating to the mucous membrane and upper respiratory tract, and they are also harmful if swallowed. Hence, this solvent must always be handled in the fume hood and the containers closed immediately after use. So now let us look at the test method for the purification of our lipid by recrystallization. So one, dissolve the crude extract in about 40 ml of acetone on a steam bath, that's around 50 degrees Celsius, in a fume hood for 5 minutes. So after that, we cool slowly to room temperature under tap water. After that, we cool further on ice to allow crystals to form. We filter with a pre-weighed filter paper. We wash with ice cold acetone, about 25 ml. Then we weigh the purified sample